Alright, hi everyone. In this example we are going to review the inverting amplifier as our introduction to operational amplifiers. So before we begin, just a quick reminder or an intro to how op-amps work. So let's ignore that problem for now. The symbol for an op-amp is a triangle, and on that triangle are usually labeled two signs, one negative, one positive. It might be flipped over, it doesn't matter. And when I say flipped over, I mean positive on top, negative on the bottom. That doesn't matter once again, but you'll see two wires, one going into the negative terminal, one going into the positive terminal, and then you'll also see an additional wire coming out of the op-amp from the pointy side on the right here. So a couple of assumptions going in. Let's give names to each of these nodes real quick. So this wire here we'll call V negative. This wire here we'll call it V positive. So the assumption is that V positive will always be equal to V negative. Doesn't matter what you have connected to any of these wires, this is always going to be the case. The secondary assumption is that the current that goes into I negative and the current that goes into I positive are the same, and they are both equal to 0. So there are actually three assumptions here in total. There's the first one that says V negative is equal to V positive. The second one says that I negative is equal to I positive. And then the third is that all the currents that go into the negative and positive terminals of the op-amp are equal to 0. And with these assumptions, we should be able to begin solving this here problem on the left. So in this problem, we're given an op-amp, and we're simply asked to do two things. The first is to find the output of the op-amp, specifically V0, which is a voltage. And then in addition to that, we want to calculate the current that flows through the feedback resistor. So when they say feedback resistor, they're talking about the resistor that connects both the left side and the right side of this op-amp. So you see in this case, that would be the 280K resistor, because it goes from the negative terminal to the output of the op-amp. Okay, so we'll start with the output voltage V0. And one note, by the way, one more note before we begin. Actually, let's just begin, and we'll uncover the note organically. So we want to find V0. We are going to do nodal analysis always when working with op-amps. You can do mesh if you wanted to, but it would be more complicated or less easy than doing nodal analysis. And so you'll always be doing nodal analysis, usually at the inputs, so the negative and the positive inputs to the op-amp. So for us, since the positive end of the op-amp is tied to ground, we're not going to do nodal analysis here, because you would be doing a nodal analysis on the ground node, which you never need to do because you'll just end up getting 0 equal to 0 for your equation. So we're going to do nodal analysis. We have to define our currents, so I'll go ahead and define it that way. And now that I've got the currents defined, let's go ahead and write out the equation. So this current here, going from left to right across the 4K resistor, I can parameterize as the 45 millivolts minus V negative. So starting from this node here, which is 45 millivolts, ending here, which is tied to V negative, and then through the 4 kilo ohm resistor. So think of this negative sign here as an arrow. So from the 45 toward V negative across the 4K. So that's what goes into the node. Coming out of the node, we have V negative minus V0. So again, got this current here, this little green arrow, goes from V negative toward V0 across the 280K resistor. And again, you think of that negative, that minus sign there is an arrow from V negative toward V0. So now you have an equation. In this equation, there are two unknowns. The unknowns are V negative and V0. So where do you get your second equation? Because in this, what we just pointed out is that we have one equation, two unknowns. You're going to get it from this right here, from where we started, from that assumption, specifically that V positive is equal to V negative. So in this case, because V positive we can see is equal to 0, we can say that V negative is also equal to 0. Therefore, the equation on the top can be simplified to read 45 millivolts over 4K is equal to negative V naught over the 280K. You can solve for V naught and you'll get 280 over 4 times the 45 millivolts. So your answer will be in millivolts, your final answer. So we're done with half the question, specifically the first half asking us to find the output of the op-amp. The second half is asking us to calculate the current through that feedback resistor right here. So this green arrow, which I'll now turn blue to make it special. We've actually already parameterized what this current is, that blue current there. And it's this right here. So let me actually turn that blue as well. Notice that we already know what V negative is. It's 0. We have found what V naught is. You just have to evaluate this. And then you divide that difference by 280K. And then you'll have your second answer for the current through the feedback resistor. Alright, that's it.